Hello, I'm Michael Taylor with Rook Security, and I certainly don't want to be known as somebody who would stand between you and happy hour, so hopefully we won't go for the entire hour. I will do my best. So what we're going to talk about is logging practices in relation to our application development, as well as using Security Incident and Event Manager. For those of you who are not aware, those of us in security use SIEMs to do our work, more or less. We need to get all of your logs, whether it's network, application, firewall, IDS, IPS, everything into one place so we can try to determine, is your system actually under attack from the Chinese government or Russian government, or your script kiddies in your mom's basement, or are things just running poorly because you forgot to apply appropriate SDLC into your environment. So you will note that I am none of the people to the right. That's because they are far more photogenic than I am. And if I'm going to upload my slides, we should all have attractive people to look at. I do enjoy tabletop gaming and D&D. So if you guys ever want to roll some D20s, hit me up. Also obligatory XKCD reference for security. We talked about earlier with James rotating our ciphers, and in security we often run into lots of different situations where trying to get clients to even begin to approach adopting best practices is a struggle. And it's not just don't write down your passwords on Post-it notes and stick them next to your mouse pad. It's even worse than that. It's don't send emails with thousands and thousands of medical records unencrypted in across your Exchange server and then proceed to save that forever, or any number of other things. So without further ado, so the general idea of this talk was I wanted to use Python to create kind of a bare bones SIEM. And so to do that, I didn't want to implement a database in Python because that's a lot of work. But what I did want to do was create an application that we could use to manage the searching and analysis of those logs. And so I chose to create a Django RESTful server. And on that server, we have endpoints to do the management of how we're going to look at those logs. So looking for signatures, and then rolling those up into packages to say, if I see these groupings of information or logs within our system, then I probably have something bad going on. And so before we can do that, we have to configure our server to use properly formatted logs. So I'm using Elasticsearch, so anything in JSON is easily consumable there. And so setting up those things, and then also doing your standard deploy things behind SSL, and ensure that everybody who's accessing your system is properly authenticated. So we, like I mentioned, we use the logs within our systems to monitor health and stability. But something I think that a lot of developers often overlook in the utilization of SIEMs is monitoring application health. Now, there are all sorts of third-party applications that you can pay for or that are free that you can use, but implementing these things in Python, since we are all enthusiasts, is an interesting thought exercise and side project. So, who here uses third-party application to monitor your application health, and what do you use? I'm sorry? New Relic, sure. And how would you say that has gone for for integration into your different projects.
It works pretty well. They changed their pricing model. Mm-hmm. Biggest struggle. But you get analytics of here's how long the request took, here's how long the SQL command took, so you get a stack of where your components on your app.
Mm-hmm. So we use Sentry.io that I've been quite happy with, and its pricing model has changed a couple times, but not significantly. And it hasn't been, whoops, hey, stop. Hasn't been too painful. So we're going to make sure we have a standard application log format. We picked our centralized data source so we can search against it without having to iterate through our entire log file every time we want to look at it. We're going to look at the correlation in machine learning to analyze those logs, so correlation being the packaging of the signatures. And then I have a few additional resources that I enjoy. We're using this API to be our centralized kind of source of truth for the patterns that we're looking for. And this is so that it's not just up to the application developer to define what could potentially be an indicator of compromise, but you can have security analysts and other people making those decisions for you. Because as I mentioned, your SIEM is going to contain many different sources, whether it's from your system logs, your firewalls, your IDS, your IPS, things like that. And so these signatures and these packages will tend to grow with in the number of facets that you have as your number of sources increase. And so the identifying that multiple failed logins, along with a firewall rule trigger, along with perhaps a system utilization increase, can all be combined together into one event to, instead of a single, oh, I'm under a brute force attack because, some user failed to log in 19 times in a row. So we have our Django app. I'm sure being Python people, we're all familiar with Django. This is our root of the API. We've got it deployed behind SSL. And so some of the interesting things that can become problematic as you're doing the deployment is setting up certificates, making sure that your Nginx is hosting things only over SSL, and that you're not using Django to host your static files. Django's not an optimal solution for doing that. Nginx or Apache or some other web service is a more appropriate process to do that, or to host those things. Also, running your Django app as a service. I chose UWSGI for that. So just the meaty bits, making sure that you're only listening on 443 for your Nginx, using the self-signed snippets to present your self-signed certificates, because I was using this just for internal purposes, so I didn't use one of even the free services. As you can see, I'm on a 10 dot address, so nobody else is getting to this. And then assigning my loopback for on port 8000 as where my UWSGI is getting pointed to. And so then if we look at our sites enabled, it's symlinked in the repository that I'll open up once we're done here to look at a socket request, or a socket connection rather, for our Django server, and then we are hosting our UWSGI parameters in our Nginx folder. And then we're running the UWSGI in Emperor mode, and this is so that we can run it as a process. And so we have to tell it where our Django base directory is, where our WSGI file is, and our virtual environment home directory. So just getting all the core things going, and now we have our Django import settings for the application and running the web server. So, okay, so we've got Django up and going. It's protected. We're ensuring that everybody who logs in is authenticated. So if we go to our web server and we don't provide any authentication, we're going to meet with an error, unless I'm still, yeah. So we get a forbidden error. Excellent. Good. And it's as you can see, self-signed cert. Chrome knows that not to trust anybody, just like Mulder. Happy about the new season coming out. I'm excited. I use the REST framework, and then the Django logging module was the second additional app that I use, and that's because it, out of the box, does JSON encoding for the logs, which was important. But as we'll see, all is not sunshine and rainbows, even with things encoded in the JSON format. And we have our Django logging middleware as well. So if we look at our RESTful endpoint, hey, look, I can get a 200 response, I can list my packages, I can see the dependencies for the signatures that are included in this package, and away we go. So we have our logs. They're in JSON format, so that should be no problem to ingest into our database, right? If it's JSON, it's JSON. Everybody should be happy, should just work. Well, that's actually not the case. The care and feeding, as well as the formatting of your log files, is highly important to being able to appropriately process your data. So even if it's valid JSON, you might blow up your database by sending every log in that you receive if you don't format it properly. That's why there are things like logstash, grok parsers to get things into a more manageable state. So why do we think that this format of JSON might be a problem for the analysis of our data? It's because everything is under the root of info, and then below info, everything is under an additional unique key. So we have two levels of our JSON hierarchy that are going to cause Elasticsearch to think that every single time I see info and then a unique key, that's a unique structure. It's going to make it impossible for us to do any kind of correlation or analysis on, say, the request data, request.data.active field, or anything below that. I'm never going to be able to do good analysis on this data structure. So what we need to do is reformat that before we ingest it into our database. So who needs logstash? Well, everybody, but for our purposes, we are doing this in Python. So I wrote a log parser. So we read our log line by line. I've got a effectively tail tacf function as well. And so we sit there and we look at our file and we read it, and continually check to make sure we're getting new lines, and we flatten that JSON into something that Elasticsearch is going to be able to give good results for and allow us to easily analyze it. We also add timestamp. Elasticsearch uses the @timestamp field for its date histograms as well as its indexing, so that you can look at things across time. And then we return our output JSON. So now that we've done that, our JSON is much more easily managed. We have a flatter data structure, and now we can do some correlation on that. We've got a log parser, and so this is how we ship data to Elastic. It's quite simple. As long as you make a connection, you can ship a JSON body to Elasticsearch and it will ingest it. There are more effective ways to doing this. For example, using the bulk import with Elasticsearch will allow us to move a significantly higher volume of data rather than this, which is doing line by line. But again, kind of getting a minimum proof of concept for creating this system. So, all right, so we can see our data in Elastic or in Kibana. Kibana is the front end for Elasticsearch, and you can see that all of our fields are flattened out, and we even have interesting things happening already. You know, for example, you know, forbidden status for our request data. So, you know, who's doing something that's not nice? Well, it turns out, you know, it's an admin that's doing something that's not nice to our system. And, you know, given that there's only one user, that was me, what was I doing? And as an application developer, you know, I would want to know how is it that me being the sole user of the system is already breaking things. So let's try and find out. So we've got all this data. So now how do we identify whether we are in a situation where we're potentially under attack or there are security events going on that should require additional attention, or even if we're in a scenario where our application performance is degraded. You know, our requests having increasingly long times to respond, and why might that be? So one of the reasons I enjoy Elastic is because of the rest of the stack, and so one of their new modules is their machine learning module. So you can see here on our histogram, we have a few different red dots, and you know, as everybody knows, red dots are bad news. So if we look here, oops. No. We can see our anomalies, and so any of these are outliers, and they're relative to the rest of the data in our system. And so one of the ideas is that not only do we want to be aware of the anomalies in our system, we want to be able to define exactly how we're hunting for signatures, or rather hunting for potential threats, which is why we created our API here to you know, roll up and correlate events into incidents or alerts. So our correlation packaging, we have a package that is comprised of multiple signatures, and each signature is related to a source. So it wouldn't make sense. That's interesting, the way that renders on the screen. So each signature is related to a source. So it wouldn't make sense to have a signature related to a firewall rule, related to my Django application source, right? So we need to know if I'm, for a particular source data feed, whether it's, for what application or network data type we're looking for. And then we roll all of those up into one package, which is saying these things are related events that I would want to group together so that if I see any or all of these in combination at a certain number, I want to do something about it. So as I just mentioned, each source is an individual data stream. So whether it's auth log or syslog or your firewall, I want to structure that query separately. So I could be looking at multiple databases or data stores for that information rather than having just Elasticsearch or just SQL or just MongoDB to group this information together. So here our correlation sources are our Django logs, our syslog, and our auth log. And for our Django log, I have my index pattern being the logstash Django log, even though I'm using Python to ship. I have a muscle memory of naming everything logstash hyphen. They've got their hooks in me. And so now our signatures are a specific query for the source that we're interested in. So am I looking for 403 forbidden codes in our HTTP responses? Am I looking for access denied? Am I looking for login patterns or particular firewall rules? And so that's where, just like training machine learning algorithms, understanding how to write these signatures and at what thresholds is it appropriate to set these query levels to be is part of not only understanding your system, but refining these as you go. Things can get awfully noisy if you set the thresholds too low. And so one of the example queries here is a fairly simple, small Elasticsearch query. And what we're saying is that our phrase must have our query match phrase must have a response status of 403. And we're looking between now and 1 hour ago. And so we roll all these up into a single package, and now we can create an alert off of that. And so we group a series of these packages together so that we can say, if I see these signatures in our data set over the period that we define as our time to live. So if we see these signatures trigger within the last hour, count them. And now we're going to say that we will create an alert, and that alert will exist for a day as we, so that we aren't constantly creating additional alerts for the same signature package. Oops, come back. And so here is the package generation. We're basically bringing everything together from our RESTful API. As you note, will note, I'm not particularly proud of this particular section. I was working on the Django backend, and I didn't get my foreign keys to reference properly, so I had to manually construct things here rather than doing it in a much more sane manner. But we're all Python fans here, and in the sake of honesty, this is how it works. And it's ugly, but it does work. So we are generating our packages. So we iterate through our packages, get our signatures, get the URLs for each of the signatures, wrap those up, and then get our recommendations, so, apply a firewall block rule or what have you, and then set our package's larger data structure into our engine object. And then within our engine, for each of the clients that we have, update those packages, and then for each of the package and for that client, apply that search, and then compare the hits for that search to the package threshold. And if we are at or more the number of hits for the package, then we go ahead and process the alert. And the alert processing portion looks at the current alerts that are active and says, do I need to add these new events that we see to an existing alert, or do we create a new alert to our system? So where do we go from here? Streaming and machine learning on streaming data is, a different subset than streaming or than doing machine learning on static data. And depending on what type of data and what you're after, you have different considerations for the algorithms that are available to you. The anomaly detection that is available directly out of Elasticsearch, while it's nice, is not going to be able to give you the clear definitions of exactly what you're after, or in a well-defined manner. You get outliers, and you can receive email alerts, but you don't have a structure for saying if then that. If I see 25 brute force logins from one user or one IP, then do something. Because if you're having that number of failed logins from multiple different systems, your trend analysis from the built-in anomaly detection system will all scale up in the same manner. So you can get hidden anomalies without realizing it. So that's why you combine these machine learning algorithms or reinforced neural networks or whatever the system you might choose, along with some other structured querying of your data. So, and then knowing what you're hunting for within your data, as just a regular web application developer, how much machine learning do you really need to do on your application logs, or do you just need to know, are my SQL queries are trending up and up and up, and I don't know why. And so I have some additional resources that I've used in the past, and I especially liked the Etsy Skyline. That was fun, but it's deprecated. And PyTorch is interesting as well. So, any questions? I did a very quick and dirty POC of it, but I haven't used it in production. Sure, yeah. Let me pull it up. So, Prophet is great for, so it's predictive analysis. So this is a tool that Facebook has developed that is used to try to let you know when you need to scale your systems to have more resources, or when are you reaching this inflection point of absolutely going from a steady increase in traffic to the point where you're hitting the hockey stick. You hit Reddit or something, and 45 minutes later, your servers are about to melt. Hey, there we go. So it.
Really still. Chicken's coming. Wait for dead chickens.
I mean, I'll sacrifice some chickens. I'm not opposed. Was it really? So what's great? It's in Python and it's in R. As somebody who doesn't want to incite the flame wars, that there's no one tool that's always the right answer. As great as Python is, there are other tools in the shed that can be used for other things, and R happens to be one of those languages that is useful for machine learning and data analysis. But they have Python libraries that you can just drop in and throw your data at it, and you're going to start getting responses. So it's fairly automatic. It's not completely, just drop in and go, but it's about as easy as you're going to get. If anybody's used pandas and NumPy for data analysis, yeah. If you're familiar with those types of libraries, you're not going to have a terribly difficult time. So one of the things that I was using is for time series data. So with it, hey, there we go. All right, okay. So time series data, it's one faceted data. So I have a value and I have a date timestamp, and I want to know what's happening to that value over time, like our request responses, or how long does it take for our API to respond to a request. I want to know the trend of that, and so we can use Prophet to look at what the prediction is. Am I tipping over my SQL server because these requests are getting increasingly inefficient over time, or as my user base increases, or as the length or number of articles in my database increases and I'm having to search a larger volume of data.